How to solve SUVAT exam questions. Number 4. A. Indicate with ticks in the table below which of the quantities are vectors and which are scalars. So, velocity and speed. Velocity is the vector, speed is the scalar. Distance and displacement. Distance is the scalar, displacement is the vector. B. A tennis ball is thrown vertically upwards, downwards and bounces on the ground. The ball leaves the hand with an initial speed of 1.5 meters per second at a height of 0.65 meters above the ground. The ball rebounds and is caught when travelling upwards with a speed of 1.0 meters per second. Assuming that air resistance is negligible, part 1, show that the speed of the ball is about 4 meters per second just before it strikes the ground. It is sure that we need to end up with 4 meters per second. So, our final answer is going to be approximately equal to 4 meters per second. So we write down SUVAT, S 0.65 meters. That was the height. U, the initial velocity, 1.5 meters per second. V, the final velocity, is our unknown. It says show that we're going to try and end up at 4 meters per second. A, the acceleration, is due to gravity, so it's 9.81 meters per second squared. We have no information on t, so we use the null t equation, which is from the data sheet v squared equals u squared plus 2as. So, substituting, v is our unknown, squared equals u squared 1.5 squared plus 2 times by gravity 9.81 times by s, the height 0.65 meters. In this one, the initial velocity and the acceleration are in the same direction, so we keep them with the same sign. Simplifying, we get v squared equals 2.25 plus 2 times 9.81 times 0.65, 12.753. Add those two, that's v squared, so we get v is the square root of 15.003, which is 3.87 meters per second to 3 significant figures, which is approximately 4 meters per second. 2. The ball is released at time t equals 0. It hits the ground at time ta and is caught at time tb. On the graph, sketch a velocity time graph for the vertical motion of the tennis ball from when it leaves the hand to when it returns. The initial velocity x and the final velocity y are marked. Ta is when it hits the ground, so at that point from the previous question it's going to be going down at 4 meters per second. So our first section of the graph, you have to excuse me, I don't have a ruler, is in that direction. When it rebounds, it is going upwards, but it goes upwards with the same speed, assuming the collision is elastic, so it's going upwards at 4 meters per second and slows down to y. So our graph looks like that. C. In a game of tennis, a ball is hit horizontally at a height of 1.2 meters and travels a horizontal distance of 5.0 meters before reaching the ground. The ball is at rest when hit. Calculate the initial velocity given to the ball when it was hit. So, this one's a two-parter, it's a little more difficult. We're going to say first, what do we know? SUVAT, it wants the horizontal velocity, so we'll say horizontally. What do we know? It goes horizontal distance of 5.0 meters. Its initial velocity is what we're trying to find out. Its final velocity we have no information on. No information. its acceleration is 0, we're assuming no air resistance. We don't know the time, we have no information. So we're going to need to find that out, but we still don't have enough information yet. So let's consider vertically. SUVAT. The distance is the height above the floor, 1.2 meters. The initial velocity is 0 meters per second because it starts from rest, it is only travelling horizontally. Its final velocity we have no information on, so we're going to use no V equation. Its acceleration is gravity, 9.81 meters per second squared. The time we still don't know, but now we can find it out. We've got 3 things, and now for the SUVAT equations we always need 3 things to be able to solve them. 3 things, one with no information and one that we're trying to find out. So using the no V equation, the datasheet says S equals ut plus a half at squared. So I'll write that down. The no V equation vertically gives S equals ut plus a half at squared. Substituting in, that gives us S is 1.2 meters equals ut, u was 0, that term is 0, plus a half times gravity times by t squared, what we're trying to find out. So 1.2 equals 9.81 divided by 2, 4.905 t squared. So t is the square root of 1.2 divided by 4.905. So t is equal to 0.495 seconds to 3 significant figures. Now that's the time it takes to fall, so that is our horizontal velocity, our horizontal time there. So now we can use the no V equation horizontally. S equals ut plus half at squared. S is our displacement, 5.0 meters equals ut, u is what we're trying to find out, t 0.495 plus a half at squared. Acceleration is 0, so that term is 0. So all we're saying is u equals 5.0 divided by 0.495, which equals 10.1 meters per second to 3 significant figures.